Today's stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause today's stream is about to start. Get ready wherever you are, 'cause today's stream is about to start.
Yay.
Hey, how's it going, everybody? We'll let people come in probably, so we'll just kind of talk a bunch of garbage at the beginning. But hey, we got a special guest today, right here.
That must
Did I
be
do
me,
it
I
right?
guess.
Yeah.
Hello, I'm Florian from BasteIn.
Yeah. Good to have you on, and I have below me Leandro. How you
Hello.
doing, Leandro?
So nice to finally meet you in person here on this
Yeah.
in this stream, because you have made plenty of interesting videos, and you also have joined us in the chat before, so it's nice to finally get to meet you in person.
Yeah, totally. I feel very delighted about it as well.
Awesome.
What is the origin of your name, Flo? As in origin of your channel name?
Oh, Beats basteln. Okay, that's first of all, that's German. And you know what beats are, and basteln just means crafting, basically.
Ah.
It's basically a less professional way of saying that we produce music. Something more playful, you know?
Oh, okay. I always thought it's just English like basting, and I was like, oh, like basting beats, cool. Like
Wait, what is basting?
basting is okay. So when you're like making like a big piece of ham or something,
Oh.
you baste it with
okay,
like some
Just
liquid.
Googled it.
Yeah. So I always thought it's that. I was like, oh, cool. But yeah, I mean, crafting is cool too. We got some people in the chat, the usual suspects. We got Mage, we got Bo. How's it going, Bo and Mage? Good to have you here. And we got some other people hopefully showing up soon. So yes, well, we know what we're doing. We're going to talk about pitch tracking, because I like to track pitch, and I always found, I don't know about you two, but I always want a more kind of wide and broad version of pitch tracking, where it's not like tracking the 12 equal temperament notes that we have, like whatever. Like I want to track the pitch, but before it turns into like conventional notes, I can intercept
so just with
it
more
and put
accuracy.
more accuracy, but also like just kind of using whatever scale I want, and not only the scales that are available in like 12 tone equal temperament, but like 19 tone equal temperament, or any kind of like microtonal scales that you find in like Eastern music and stuff. And usually they're just more strict about it. It's been implemented in the background, and then they're like, you want major, C, or A minor, and then.
Yeah.
And I'm like, So that's kind of, and then I think you mentioned that you have done a video on this, right, Flo?
Yeah, I've made a video, and it's actually, I think it's actually one of the most popular videos that I made from the beginning of my channel for some reason. I guess people were kind of fascinated about it, that you can just take FFT, the basic FFT from Juice, and get the maximum magnitude, or the bin with the highest magnitude, and then you already know more or less on which frequency you are. So you can just go to the nearest pitch of the given scale that you have defined and attach that to an oscillator, and suddenly you can play with your voice a synthesizer.
Nice.
Yeah.
That's awesome.
But it's very inaccurate and also kind of slow. So you always have this compromise that you know from FFT type of effects. And that wasn't on purpose. So in the beginning, I also wanted to have something that is just 100% accurate, where you don't have to select a scale also, like you said. But I actually let it round to the nearest pitch on purpose to get around this problem.
Okay, I see. I
actually
guess
have
for
a
a
question.
synthesizer, that makes...
Yeah, I have a question
Go
about
on,
the
sorry,
purpose.
Dan.
Because you were talking about synthesizers that are tracking your singing, but when I started looking into this, it was for something much simpler. I just wanted to have a tuner. I wanted to build a tuner, a guitar tuner. And that's how I started learning about these techniques and all. So besides a tuner, and I guess in your case, the purpose is to do a synthesizer that is controlled with your voice, or are you also interested in trying to do some auto tuning, or what are you looking into? Why are you looking into pitch tracking?
I mean, it was one of the first things that I ever did in Juice, so I didn't have a very good or structured way of getting into this problem. Nowadays, I would just do it the same way as you, and first start small and just make a tuner, and only then go on with something bigger. You know, just try to nail the basics before going big with a thing. But I just wanted to get stuff done fast, and my idea was just to make a little synth, so I did that.
Nice.
How about you, Arya? Why are you interested in pitch tracking?
Yeah, like microtonal stuff. For one, so I have there's a plugin called Waves Tune Real Time, which is kind of like the Waves version of Autotune. And in that, there's a very small number of microtonal scales that are baked into it, but you can't add any. But so what I found was, like, I don't really sing, but what I found was if I make the speed as fast as it goes and the transition as fast as it goes, I can just play guitar through it and it'll correct to the nearest pitch. And it usually just works out. But then I'm limited to the number of scales that they got over here. So what if and then whenever these days, whenever I find a limitation, if anything, I'm like, hey, let's talk to Leandro about this. And then now I got two people to talk about this.
Sweet.
Yeah. And with synthesizers too, like, there's a lot of kind of voice controlled synthesizers. But again, I think they limit themselves back into 12-tone equal temperament. So the only thing you gain by using your voice is that you're not playing keys. But, you know, like, it'd be nice you can... Because with your voice, right, you can transition between two frequencies in many different ways. Like, I can go from, like, a root to a minor third in, like, 5 steps or 4 steps or whatever. And it'd be nice if, like, your oscillator would kind of just track the frequency and then go on that journey along with you. But usually, since synthesizers are, like, triggering something in MIDI, that's 127 values for note 128. It always comes and falls back into this... falls back into 12-tone equal temperament. So I really am trying to, like, bust out of that, and that's why I'm super interested.
Very good. I really appreciate it, because I think there is not a lot of microtonal support in plugins yet. I would love to dive into that, but I just hate using tune files or having to open Scala to make on my own tune files. It's kind of a nerdy activity, and these kind of things should be more accessible. They should be so accessible that it feels normal to use them.
Totally, yeah. And when I heard MIDI 2.0 is coming out, I was like, microtones.
Yes, me too.
And I think there's gonna be some structure for that. But yeah, I agree. We gotta, like it's time. It's time we break out of the regular notes, man. That's what the man wants you
So
to
what's
play.
interesting about this is that you are not really interested in the pitch tracking as an end to itself. You are interested in the quantization that happens after the detection. So you could just take something off the shelf that does the pitch tracking and then work from there to do the bigger product that you want to do, the plugin itself. Interesting.
I think it's the same thing actually, because if your pitch tracking is not accurate enough, then it forces you to quantize in some way. Otherwise, the output will just not be very desirable. Only if you had perfect pitch tracking, you could completely ignore that, and that would be cool too, of course. You could just, even in the context of a synthesizer, if someone was a very good singer, then they could incorporate their natural vibrato into the synthesizer sound. Of course, it would be awesome, but that's just the problem with all these pitch tracking techniques.
Yeah, so we also need to then have something more kind of accurate.
Yeah.
Like, and fast and accurate.
Well,
the more
and
accuracy we get,
hang
the more
on.
we can.
If you
keep
think
the
about
thing
my example of the tuner, it also needs to be relatively accurate, and it goes between notes because that's the entire point. So I suppose that anything that would work for a tuner that works in real time would work for this purpose, I think.
But guitar tuners are always very weird. Did you ever notice how much they fluctuate all the time? They never stay on one value, and I think for a visualizer you can just have that happening because you can just deduce what it's trying to tell you. But for something that should process audio, you want something that is a bit more of a clean signal.
So are you saying you just want to low pass the result, the signal that comes out of the pitch tracker?
Yeah, and the result that comes out of the pitch tracker has to be accurate on its own already, so that the low passing actually lets it end up on the right value.
Interesting.
That's how I suppose that it works.
Fernando is asking if y'all have heard of the language Chuck. I've not heard of it.
No.
Yeah, I know. It is a domain-specific programming language. So it's a programming language for processing audio, but I don't know much about it. I know it exists. I looked at some examples of code, but I haven't worked with it. I have no experience with it. Do you have experience with that? Is that why you're interested? Do you think we should be looking at it? Let us know.
No, Fernando asked. Fernando, tell us about it. If you have experience with it.
Yeah, that's who I'm asking this.
Oh, sorry. I thought you were asking me, but yeah, that makes more sense.
Yeah.
And so also, I guess, Flo, you use Bitwig and you code in C and then you use Juice. But today, in the interest of speed and developing something in real time and not having to compile and all of that, we're gonna use We're gonna make a JSFX. Do you have experience with that? Have you seen stuff around JSFX other than in Dan World videos, I guess?
Yeah, I mean in these streams that I sometimes also participate in and watch, I see the language, but I have not written myself, no experience, so I cannot contribute as well as you two can. So I'm more here for the general topic and because it's cool.
Yeah,
cool. Well, probably you'll still have more to contribute than me.
Yeah.
I know.
So I guess before we get into the code, it would be worth talking about the space, because pitch tracking is probably one of the first problems that people tackled in this whole area. It is a very well-known problem, and there are many techniques already. Some people even consider this a solved problem, though people are still working on new techniques to this day. But I guess in general, if you want to track pitch, there are two broad ways of doing it, as in many other tasks in processing audio. So you can do it in the time domain or in the frequency domain. And in your original implementation, in your video, you implemented this in the frequency domain. You took the FFT of the signal and you looked at the bin with the maximum magnitude. And
Yeah.
that's perhaps the most straightforward frequency domain approach. And
Yeah, if you have an FFT implementation, it is pretty straightforward.
exactly. Now, the problem with this, and I guess the problem with frequency domain approaches in general, is that you need to introduce some latency because you need to accumulate a bunch of samples before you can even take the FFT of the signal. So you have to wait for 512, 1024, maybe 2048 samples before you can do the FFT and then look at the bins and find the maximum magnitude. So that's why some people prefer to not do this in the frequency domain. And even in the frequency domain, there are many other approaches that perhaps would have better precision and whatnot. But I am particularly interested in the time domain approaches because I am interested in real-time processing. So tuners and I guess even the pitch correction that works on the guitar or on the voice, or even playing a synthesizer with your voice, in all those cases, you probably don't want any latency. And time domain approaches tend to be better in this aspect. And there are more advanced techniques that look at the autocorrelation of the signal. So if a signal is periodic, if the signal is tonal, you can probably take a chunk of it and slide it over and find that it correlates with itself, and then the length of time that this period is will determine the frequency. And there is an algorithm that I think we should implement at some point because it seems to be one of the best, and it doesn't seem to be too complicated. But I have this idea that I ran by you before, and I'm not sure you buy it or not, but I think that perhaps we could try and do something that we can actually finish in this coding session, and that is the simplest time domain approach. So we already have the simplest frequency domain approach. You have implemented that. We could look at the simplest time domain approach, which has a bunch of problems. But we could compare them and see if the simplest time domain is better in any aspect. I hope that at least it will be better in terms of latency. But
It is definitely the best one in terms of the actual pitch that is detected in the end when it actually works.
So the time domain method, is that the zero crossing countage?
yeah, so that is not the only, it's probably the simplest and the most straightforward, the one that we can probably implement in one coding session. But yeah, it is to count the zero crossings. And I wonder if it
and
will
then
be
you
any
go
good.
like if there's like 100 every second, then that means that it's
100 hertz.
okay. Cool.
Yeah, I would
Yeah.
count the samples for that, but yeah.
Yeah, so
Interesting.
with that in mind, oh yeah, I guess I didn't mention, but the technique that I think is the more advanced one and we should implement at some point, it's in a paper, it's called YIN, and it is based on autocorrelation, and it's actually based on a couple different strategies that are combined. So you try a technique, you try another technique, and then you sort of combine the results of both and try to correct from the errors in each technique. But the simplest, most naive thing you can do is just count the zero crossings.
Yeah, let's do that.
So with the correlation thing, my question becomes, because you were saying it like takes a chunk and compares it to the next chunks. If you're like async movement,
you can let
so then they
multiple of
won't-
these things overlap. Probably. That's what I would assume.
Cool. Mage says, I've not seen a tool that can do real-time polyphonic pitch correction. I've seen tuners that can detect multiple tones at the same time. And I've seen pedals that, at least with my limited understanding, seems like they detect multiple pitch. Like I got a pedal that makes things sound like an organ. And at least from how I understand it, it feels like it tracks the pitch of multiple notes. and then it plays a sound. It's not like doing it via EQ or anything. It literally sounds like I'm using my guitar to trigger like samples of an organ. So I always thought that's how they do it. But yeah, I mean, polyphonic is the jam. That would be awesome, because then you can have like a guitar arpeggiator. You play a chord and go do 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 do.
I think it's actually solved already. Pitch map
nice.
from Synaptic. I mean, isn't that the whole point of that plugin?
I suppose, yeah. Yeah. So and then once we get a good monophonic, it'd be nice to get into polyphonic pitch correction territory.
But that doesn't sound like something that we get done today.
No, not today. Yeah. No. We usually, our MO on this channel is a lot of incomplete stuff, and then we move on to something else. But, hopefully the 6 of you who are always here are learning a lot of stuff. I know I am.
Yeah, I am interested in diving into different topics, and then the ones that stick around are the ones that we explore more deeply, like data bending is something that I'm getting deeper into.
Yeah, exciting stuff. So shall we get into it?
Oh yeah. Let's do it. So I have here in front of me this file that I started, and I think both of you also have access to this.
Mine is still spinning.
Oh, really?
Let me check. Yeah,
on
mine
the
too.
browser.
What's going
Yeah.
on?
Oh, well, that's too bad. So you won't be
But
able to
I
actually
could also
type into
just-
the thing. Maybe you can just try reloading the tab and see if that works. Because for people who are watching, what we are trying to do is use this Visual Studio Code live share thing, and then we would all be able to type together. But even if we are not able to type together, I think we should be able to talk about the code, and I can do the typing.
So breakthrough in our case, I'm using Chrome, Florian. I don't know if if you use the same thing, but there's an icon in my address bar that I need to click on to actually start installing the thing. Otherwise, it's not doing anything. So once I hit it and gave it permission, it's coming now.
Interesting. I don't remember doing that step. I don't know how it worked for me, because I tested this before I suggested it, and I guess for some reason it worked for me before. Maybe I clicked on the thing, I just don't remember.
Maybe they just added this because people were like, hey man, I went to this browser thing, and then it installed a huge thing on my system.
Yeah, well, I guess what you are doing is agreeing to install a progressive web app, and I don't remember having to do that.
Yeah.
Anyway, so here we are. Let's do something that will count 0 crossings and predict the pitch based on that. So I suppose that we can start with a slider that will show us the output. In JSFX, a slider is usually an input, but it's kind of a hacky way for us to see the output as well. So let's have a slider that I will call pitch, or maybe
So
even
it's a
just
parameter,
frequency.
like in Juice?
It is like a parameter in Juice, yes. And I guess I will call this frequency, not pitch, because the whole point is that we are going to quantize this in interesting different ways. So let's just get the frequency and then worry about pitch later. And
Let's keep it as simple as possible.
yeah.
From beginning.
So because this is going to be an output, I guess the range can be from 20 to 20 kilohertz and in steps of 1. And then I guess we can go to the sample section actually. And I want to prove that we can use this as sort of a hackish output. So let's do this. I will take a counter that I will initialize, and we will throw this away. I'm doing this just to show that this can work as an output. So the counter is going to start at 0. It's going to be incremented if the counter is bigger than, or I guess it's going to start at 20. If it is bigger than 20 kilohertz, then counter goes back to 20, and frequency is now equal to the counter. So now this should be cycling like crazy. So we expect the slider to be going from left to right like crazy. And this will prove that we are actually showing outputs.
And the slider will update?
I suppose.
Like visually? Okay, cool. I didn't know that you can do that.
And
That's a very easy way to do that.
Yeah. How do you like them apples?
so here we are. We can use a
Nice,
slider as
okay.
output. And that's what we're going to do. So let's throw this out. And think about how to do this zero crossing thing. I have already thought about how I would do this, but I would love to hear from both of you if you have ideas of how to go about this. We could always just get something off the shelf, but I think it would be nice, since it's such a straightforward thing, it would be nice to try and work it out from first principles. So how would you do this? How would you start?
I would store a variable for the last sample. So for every new sample, I would check if the last sample has a different sign than the current sample. If yes, we have just crossed the 0 line. And then, of course, the current sample would then become the new last sample. I think that's already it. One thing is still missing. When 2 zero crossings have been reached, so there has to be a zero crossing counter that always cycles between 0, 1, and 2. So, you know, like modulo 2. So whenever it has reached the end of its cycle, we would count the samples. Oh yeah, we would also need a variable for counting those samples then. And then the amount of samples can tell us which frequency we have, of course. That would be my
Nice.
solution.
Super cool.
Why would you do it differently, or?
I would, but I want to hear from Arya.
I was thinking very basic. I like your idea of like, yes, kind of checking if the sign changed. I was literally just going to be like, well, every time a sample is 0, that's
that
our
would
0.
work, I think, because you would cross it oftentimes without any sample being exactly 0.
Exactly. Yeah. So yours is, I think, much better.
Yeah, there is one interesting thing about this. You are, if I understand correctly, you are trying to first listen to audio, detect 1 zero crossing, then start a counter and keep looking for another 0 crossing. When you find another 0 crossing, you take this measurement, and that is your period, right? That is your
There has to
idea.
be 2 zero crossings at every second.
Yeah, 2 0 crossings is 1 period.
Because if you imagine a sine wave, it
Oh
goes
yeah, absolutely. Okay,
up,
so you would
then it
find
goes
2 zero
down.
crossings, and then you would say that that is your period. And that is interesting because what you're doing is just trying to measure the length of, try to measure the period. That is interesting. That's not how I thought about this. So I'm going to run my idea through you and by you, and you see which one we should implement, or if we should implement both, because they both sound relatively straightforward to implement. I think we can pull this off. Anyway, my idea is we would have a window, let's say 200 milliseconds. And we would keep this window sliding. So as soon as a sample comes in, we slide that window. And when another sample comes in, we slide that window. So we are always looking at the most recent 200 milliseconds worth of samples. And then in this window, we would count all the zero crossings that happened. Maybe 500 zero crossings happened. And in that case, we know that 500 zero crossings happened in 200 milliseconds, and then we can compute the frequency from that. And I think that the advantage of this is that it will be more stable, especially when the waveform gets anything beyond a simple sine wave. I think it will be a bit more stable. And I also think that it may be more accurate because the way that we are going to detect a zero crossing is, I guess, just going from positive to negative or negative to positive. And that negative to positive can... So one sample is negative, the next is positive. We know that it crossed zero in between, but we don't know where in between two samples that happened. It could be very close to the first sample or close to the second sample. So in your strategy, we would be quantizing this to one of the two. We would pick one, but we would be quantizing this crossing to one of the two, and then we would be taking the measurement of the period slightly off because it is quantized. While with the window, we would not be quantizing. We would just looking at the count of overall count. And I guess in your strategy, we would have faster results, even lower latency. But I guess in my strategy, the latency would be a bit bigger because the window has to slide enough to make the zero crossings of the new frequency relevant. Does that make sense, or is it like, am I getting too...
I don't know.
It
my
makes
head.
sense that the way we did pitch shifting, Leandro kind of did a similar thing, right? We like made a window, and the window is ever sliding. Tail is saying, I think I would also simply count zero crossings, but I would add a high pass filter before it and a low pass filter after the counter to average it.
But I think as a
Cool.
test signal, we should just start with the simple sine wave, just to keep it as simple as possible, and then progress forward with the more complicated problems.
Sounds
so
like
that
a
we
plan.
have something that is really robust on a very fundamental level, and then, you know, move forward from there.
We
That
go
would be my
nuts.
suggestion.
Sounds good.
I understand what you are saying, but I don't understand what do you consider to be the simplest option.
I mean, I would personally say that my option is the simplest because it doesn't need a windowing.
Fair
a
enough.
window.
So let's do this.
You are basically just counting a bunch of stuff.
So there will be this stage variable that is how many zero crossings we have found, and then the length, or I guess this is going to be the period in samples.
Yeah, that sounds
And it also starts at 0. So then as samples come in, I'm going to call this sample just to make the code slightly easier to read. I don't really like how in JSFX it's abbreviated to SPL. So
good. Okay. Sample.
we also
get
need
it.
to check this last sample thing. So let's let that start at 0 and be explicit about this, even though in JSFX, if you don't specify what a variable is, you start using it, it is 0. But now we are being explicit. So
Cool.
we need to check if a zero crossing has happened. And we can check that by looking at the sign of the sample and the sign of the last sample. I guess I'm going to call this the previous sample.
Yeah, that's also a way to call it.
And
You could also just check which one is bigger, you know, because the one that is negative will always be smaller than the other one. I don't know if it makes a difference here.
but if the sample is 0.3 and the previous is 0.2, this
That
is bigger
not
than that.
possible. I think that's not possible because once one of them is positive, the other one will always snap to negative.
Why?
Because that is the thing that happens when a zero crossing occurs. We override the sample previous with the new current sample.
But then in that case, we're not checking if the signs are opposites. Like
wait,
if
wait.
if a
No, you're
waveform
right.
is going up, right?
Sorry,
each
you're-
value will be bigger.
Now I get what you mean. Okay, we have to check the signs. That's true.
Okay, so we check that the signs are not the same, which means a zero crossing has occurred. And then in that case, we will increment this stage. And we will check if we have gotten to stage 2, which means that we found a full cycle. And we'll do some
Fun.
work. We'll
now
also,
zero's crossing state has to go back to 0 in that case.
exactly, yeah. And not only that, but with this period in samples also has to be reset.
Yeah, but we have to measure the period the whole time.
Yes, so we start at this, and then if we get to state 0, no, I guess we just keep counting every time, right?
Yeah, always just plus plus.
Yeah, we don't have plus plus, so that's why I'm being
Oh, okay.
plus equals 1. Yeah.
Well, it's the same thing.
Right. So
Before setting the period samples to 0, we could already do the frequency calculation and put it into the frequency slider.
yeah, so we can do that here by assigning to frequency.
But before setting it to 0, because otherwise it will not create a frequency.
Fair point.
Yeah.
So we calculate the frequency based on the samples, and I suppose that we will need some ingredients here. We will need the sampling rate, which in JSFX is given by us with this S rate variable, and we will also need. No, I think that may be all.
Yeah. That should be all.
Yeah. So I just
forgot if it's frequency times sample rate or frequency divided by sample rate.
Well, let's think about it this way. If we find a sine wave that is, I am working with a 48 kilohertz sampling rate. If a sine wave is doing a full cycle in 24,000 samples, that is going to be 2 hertz, because it's going to do 2 full cycles in 1 second. So I guess I just take 24 kilohertz, divide by 48 kilohertz, that gives me half. That's not the right thing. So what if I do it the other way around? Sample rate divided by the period, 48,000 divided by 24 gives me 2. That sounds about right. And that may be all there is to this.
Hey.
Do you want to test this, or do you already see something obviously wrong?
Let's do a test.
Okay.
Who we
what do you
hurting?
have? I was just in Desmos, but yeah, just test it, I guess.
Yeah, let's do a test.
We are testing this. So it is giving us a frequency of 440, which is correct. It is the frequency
Cool.
here.
Now move the frequency. Let's see what happens. Nice. By the way, can we give the frequency slider a logarithmic
No, that is unfortunately
range?
Yeah, that's unfortunate, but no, it has to be linear.
Okay.
Interesting. So it is working well for low frequencies. It's still like glitching a little, but then the low pass could filter this out. But on high frequencies,
sine wave currently,
this is a sine wave, yes.
but it should never be glitching when it's just a pure sine wave. Now
Well,
As you change it, it changes. But there's one thing about this tone generator. I don't know if every tone generator is like this, but in the moment where you change the note, you see some junk in a like spectral viewer. I don't know if every sine tone generator does this, but I know with this one, like you get a moment where you get a burst of frequencies.
yeah, that would explain it.
no, that would not explain this, because we are not moving the frequency right now. It is stable, but
Well,
look, it is
that's
still
true
glitching.
too.
Oh, gross.
Why?
Well, because think about the way that the samples are going to land, especially on high frequencies. This is on low frequencies, we have enough samples that the sine wave looks almost smooth. But as you increase the frequency, in this frequency, for instance, it seems like the whole cycle is represented by what, 8 samples? Something like that?
But there should still be no problem.
Well, there should be a problem, because now the 8 samples are not always right from the start of the sine wave, and then reaching right the end of the sine wave, because, well, if you pick a frequency that is that divides the sampling rate equally, so if we pick
2,400 or something.
What is 48 divided by 4? It's 12. So if we pick 12 kilohertz, then you can see that, yes,
It's
the
gonna be
samples...
perf.
Yeah, the alignment is perfect between samples and the period, and then our implementation works just fine. It doesn't glitch. But as soon as you deviate from that, then you are sort of wiggling around, because there is a perfect alignment between the sine wave and the samples. We are wiggling around. And remember that this representation here with the staircase is not really accurate. What is really happening is that the signal would be reconstructed smoothly using an anti-imaging filter.
Right.
So it's not like we're losing any information here. This representation is kind of glitchy, but we are not really losing information. But at the sample level, it's not really aligning. And because we only have so many samples, like in this case, I guess at this frequency, we sort of have 4 samples, and that is a complete period. Now, the zero crossing is happening between 2 samples, 2 consecutive samples. But again, it may be happening near the first sample or near the second one. And in this high frequency, this matters. And our quantization is introducing this kind of noise.
And it's interesting that it's going between 12,000 and 9,600, which are both perfect integers of our sample rate.
Yeah, I guess with our strategy, we are limited to that because of the way we are doing this. This is going to be an integer. It's going to be our sample rate divided by an integer. And
can we look at this in the spectrogram or something? In a spectrogram?
Absolutely, yeah.
I just want to know how clean this signal generator is.
It's pretty clean when you don't change it. And then just the moment you change it, there is a little yoinkification.
How deep does this spectrogram go?
You mean in terms of the noise floor? It is really low.
Totally clean. Yeah, that's perfectly clean. That's better than serum. Okay.
Non-linear JSFX sliders are coming soon, says Tail. Nice.
Oh, that would be great.
But then you give it, you have to give it its non-linear. Like, you have to define the slider movement, and it's just not going to be in steps. It's going to be in something that you, code.
It's probably going to be something like Juice, where you just say it's logarithmic or exponential or something.
Right, okay.
Well, in Juice, you can even go beyond that, and you can say ranges. From 0 to 0.3, it is logarithmic, and then from 0.3 to 0.7, it's linear. So I don't think in JSFX we would have something like this, but it would be great if we had it. But anyway, so the problem here is that what we are doing is we are thinking of samples. In our code, we are thinking in samples this way. We are thinking in samples in this stair-step way, which is a zero-order code, which is the most naive way of thinking about samples. One way we probably could improve on this is to interpolate between the samples, not with a stair step, but with a line. So we would be doing linear interpolation, and we would be looking at the 2 consecutive samples that are around the zero crossing, and we could see if the number is like -0.1 and -0.7, we know that the zero crossing is closer to the first sample. On the other hand, if it is between -0.7 and 0.1, we know that the zero crossing is closer to the second sample. And if you take that in account, we will no longer be taking just an integer number of samples, and we could improve on this a little bit. Do you want to try that, or do you want to try the window?
So,
on that.
So what you're suggesting is gonna make more frequencies accurate, but not all, right? Basically.
Yeah, it is probably just going to give us a couple values between 9600 and
12,000.
Yeah, it's just going to give us a couple
Cool.
values between that. And I
we
believe
need
it
more
will may
net.
also alleviate for the sine wave, because the sine wave is such a simple signal to work with. For the sine wave, I think it's going to improve on the glitchiness as well. I don't think it's going to be jumping so quickly. As soon as the waveform gets anything a bit more complicated, it will jump up and down, because then there will be zero crossings that are not part of the, that are going to subdivide the period in more numbers. So we would be catching higher harmonics, and that will glitch, I think. But we can try that. Do you want to try it? Yeah. So here what we do is when we find a zero crossing, where I guess when we find this second zero crossing, we need to take this in account. So how can we do this? I want to do a linear interpolation between sample and sample previews. And I guess I will add that to the period in samples. Let me think about this. I guess one way to do this is to correct the period in samples. So first we correct from this addition that should not have happened, and then we add something that will be the linear interpolation between these two guys. I guess we could take, here's one idea, I'm just thinking this out loud, but we could take the absolute values and divide one by the other. Is this the right way of doing this?
You'll get the midpoint between... Well, you won't get the midpoint between them, though. You get... like if one is at minus 0.1 and one is at plus 0.3, you'll get 0.2, which is closer to 0.3 than it is to minus 0.1.
You can't do that because sample previews could be 0.
Yeah, you're
and
right
it could
about
be
that.
0. Oh, there you go.
Yeah, so what I want is for this, the thing in parentheses, I'm going to remove the absolute values because I think that that's a bad idea. But what we want is if sample is 0 and sample... No, if sample previous is 0 and sample is something like 1, then we know that the zero crossing happened near previous, and we want to add to the previous, to the period in samples, we want to add 0. I'm doing this as kind of code, but it's really a comment. I'm just thinking this out loud. And alternatively, if we are going from 1 to 0...
What does adding 0 do?
It is saying that the period in samples lands right on the previous sample.
Oh.
And this is the other extreme, where the previous sample was all the way up and the sample is at 0. And in that case, we want to add 1 because the period in sample needs to take in account that whole space.
I'm not sure
Gotcha.
if that's actually a reasonable approach, because if you think of waveforms like saw waves, of course there would always be a very large value between sample previous and sample because, you know, of this whole step where it resets. But that doesn't mean that we have to add any values to represent that frequency. It is still just the next sample that resets the thing.
Yeah, I'm just
There
trying
must
to
be a
think of...
different
I'm
reason.
trying to think of the extremes here. Now, in reality, we will probably see something like the previous sample was minus 0.1 and sample is something like 0.3. And then we know that the previous sample is closer to the zero crossing than the sample. So in that case, we would add something relatively small. I'm going to just put 0.1 here as a placeholder for something relatively small. On the other hand, if it went from something like minus 0.7 up to 0.2, then we know that the zero crossing happened closer to sample. And in that case, we want to add something like 0.8.
Ah, yeah, get it. Cool.
Now, the problem is that I don't really know how to turn this intuition into a formula.
Yeah, I can also not do this from scratch, but I always open Desmos for these kind of things and just play around until I find something, so I do that.
Well, I guess we could look at how to do linear interpolation, and we have done this before together, Arya. Do you remember that?
Yeah. Was it for... What did we do that for? Was that for the pitch shift or no? That was...
It was for the delay, the ping pong delay, because we wanted to be able to modulate the delay.
Yeah. That's right.
And this is how you do linear interpolation. You take a weight and you do this formula. But the problem is that in this case, we know what the weight is because we know where we want to be between two samples. So you have a sample called sample 0, you have a sample called sample 1, and you're interested in sample 0.27. 0.27 is somewhere between 0 and 1, and then that's the weight. But now we have the opposite problem, where we have the endpoints, and we are trying to estimate where 0 is in between these 2 points. So we sort of want the inverse formula from this. Does that make sense?
Yeah.
Oh, here is something. We could add and divide by 2. Yeah.
Add, so that it's never 0, and then...
Yeah, let's just add and divide by 2.
Subtract, you mean, right?
No, I mean this. Let me write what I mean.
Okay.
Now, if the zero crossing happened, let's work through the examples. So if the sample previous is 0 and sample is 1, we add half. That's no good. That's not what I wanted.
Can I share my screen?
Yes.
Somehow?
How do you want to do that? Do you want to share a screen on Skype, or do you want to change your image so that it has your screen in it?
Yeah, like this. I always use Desmos. As I said, can you see that?
I can see that, but you have to give me a moment to show this on the stream in a way that makes sense. Hang on.
Okay.
And then this. There you go.
Okay, cool. So we are always in a situation where we have a sample and the previous sample like here, and one of them is on the left and the other one is on the right side from 0. You know, this is a range from -1 to 1. So what I did was ABSS minus ABSP, and then I was just asking myself what would happen if one of them, first of all, if both of them are the same, just on opposite sides, like 0.25, which would result in 0, and it's the same thing when it's the other way around, which makes it very comfortable. Now, if the sample is a little bit lower in value, which means it's closer to 1, then there is a minus value. We can try if it's the same when we are turning this around. And yeah, that's definitely the same. So if this results in a negative value, then the sample is closer. If it's resulting in a positive value, then the previous sample is closer. So that should essentially solve our problem. And let's see what the biggest difference is in this thing. It is, oh wait, why does this give me 0? Oh, because it's the same. Okay, yeah. The biggest difference would be by putting this to 0. Okay, so the biggest difference can be 1 that appears here, which would mean that we're going the maximum way from sample to previous sample.
This reminds me of something we didn't ask you that we always ask everybody. Kind of what's your background and how did you get into coding? Like math stuff, you know, yeah. What's your background with that stuff, Flo?
My background is that I was always too lazy to use the higher math courses in school. So I only did that for fun.
Okay.
And that's why I always have to count on my intuition when it comes to math stuff and test a lot of stuff in Desmos and debug values and stuff like that. Because if I had to get to a result purely from theoretical knowledge, then I would be pretty much not there where I am now.
And how did you like overall get into coding?
Well, I started with plugin script, Bluecat plugin script, because you know, it is a VST plugin that just lets you write little DSP scripts in AngelScript. I bought it a lot of years ago because I thought that it would be cool to make my own plugins. But I didn't get how it works, so I forgot that I have it. And then many years later, I noticed that I still have plugin script, so I tried it again. And suddenly I understood it a little bit. The first thing that I ever did was that I manipulated a preset script that was in plugin script that just had a button that flips the signal between mono and not mono. And I changed it so that this button only let the side signal through. And that was such a nice moment that I just decided to make that the purpose of my life from that moment on.
Awesome. That's so cool.
Awesome.
All right, back to it. I just had to ask this.
Yeah, so I couldn't really read the
it's on
formula.
record.
It was kind of low resolution for me. So can you tell me again what the formula is that you want me to use?
Yeah, it was just ABS of the current sample minus ABS of the last sample. But let's put that into an extra variable because otherwise that line is getting way too long. Because we still have to do some additional stuff to that. So also, so we can give it a name, of course.
Well,
Let's see how...
I think if I understand correctly, what we want is first to compensate for the fact that we have added 1 to the period, and we compensate for that here. And then we want to add this interpolation, this interpolated thing. And it was this, and also you are saying that the number was like, the result of this was between 0 and 1 or minus 1 and 1?
Actually between -1 and 1, I think. Because
that's
the
the max
values,
range.
Yeah, the -1, the negative values mean that it's closer to the sample, and the positive values mean that it's closer to the last sample.
Yeah, so if it is between -1 and 1, and we add 1, it goes from 0 to 2, and if we divide by 2, it goes between 0 and 1, and that was the intent. So this should do it. Am I right?
Yeah.
All right.
I guess.
So let's give this a try. And I need to juggle some windows.
Currently you're just adding 1 sample to it. Didn't you want to do something with that?
You added 1, then you took away 1, right?
Oh wait, no, I get what you mean. Okay, yeah, just do the thing and then let's see.
Okay, we are getting a value between I guess it was 12,000 and 9,600 or something like that. We are getting values in between, and the values are closer to the truth, but it's still glitching. It's still jumping.
Why is it generally higher than the value that should be, though? For example, currently it's never 17,000 something, but always 19,000
Yeah,
something.
yeah.
Let's try a really low frequency to compare. Okay, so the accuracy
Yeah,
goes
Bo
up
was-
when we are.
Bo was
So-
also pointing out like the fundamental frequency of basically nothing but synths would be 11K. Like if we optimize our stuff for like pitches, you know, we should stay, I don't know, within like 80 hertz, and not
Yeah,
that we should not try to pitch detect those like higher frequencies, but yeah, we can totally like start the testing with like 400, you know, something nice and like more than like.
But I don't understand why we already have to optimize the pitch detection, because at the moment we use the perfectly clean signal, so we
Right.
still have to have an issue in our calculations, I think.
Right.
Not so sure, because what we are doing is we are, with this new solution, we are taking in
Yeah.
account that the zero crossing doesn't land exactly on the sample. On one end, when we find the second zero crossing, we are taking in account the fact that we are not landing exactly on the sample. We are not quantizing anymore. So we are fixing this on one side, but we're not fixing it on the other side. So the zero crossing, for instance, in this kind of waveform, it is not happening right on the sample on the left and on the right. And we are compensating for the right, but we are not compensating for the left. I guess this explains both why it's always bigger than the frequency it should be, and it also explains why it is jumping like crazy.
Yeah, that might be.
So to fix this, I think that what we want to do is not set this to 0, but to set it to this. Because now if it is like, let's say that we are saying that this period is 27.7 samples. 27.7 samples because we did this computation and we got 0.7 out of it. So it is 27.7 samples. Now, instead of resetting to 0, we are resetting to 0.7. So we are sort of taking in account the fact that the start of the count is also not landing exactly on the sample. I think this should improve things.
Okay.
And here's my question. If we times it by 10 and then floor it, we kind of increase the resolution, right? Because then we can see 27.7 as,
No,
you know what I mean?
No, so what we are doing is floor of 27.7 is 27, and we are subtracting 27.7 minus 27, so we are getting 0.7. But if it was
0.7.
But if it was 27.7352, we would be subtracting 27 from that and getting in the end
0.073, yeah.
the number I said. So
Cool.
I think this should
Yeah,
improve
yeah,
things
gotcha,
a
gotcha.
little bit. Let's try it.
Little bit, just a little bit.
It is closer, but it's not very good. And it's still jumping up and down.
It's
I
like
don't
the
know.
Reaper stock tuner. Oh,
Hey, I think it seemed worse than before.
I think it's worse than before. But it kind of matches what we see in the oscilloscope. And I like that oscilloscope is naive and it's showing the stair step, because the jumping that we see here is kind of similar to the jumping that we see there.
Might be, yeah.
Instead of trying to polish this even further, do you want to try the window? Because I think that the window is going to fix this jumping.
Sure.
Okay.
sure, yeah, let's get to it.
Because a window is more or
Let's
less a
get it.
low-pass filter, right? So do you want to keep this around? Do you want to keep a copy? I will keep a copy.
Yeah, why not?
And we still use this, but we don't use much else. We don't use this notion of zero crossing stage. We don't count the period like that. We do keep a sample previous because we need to check that a zero crossing has occurred. So this we keep, that we don't keep. All of this goes away. And this we keep. Okay. And then we also need to have zero crossings. That's going to be a count of how many zero crossings have happened in the window. I will have a window length, and I will fix this for now. We can have a slider for this if we want to play around with this, but for now it will be like 100 milliseconds. So if how do I compute the number of samples based on this? I never know. I have to check my library, unless you know of this off the top of your head.
What's the question? Sorry?
From milliseconds to samples.
Oh, at 48K, there's 480 samples per millisecond, which is pretty easy.
Well, that's it.
So 200 is 48, 96, 9,600.
Yeah, let's do 100 milliseconds. Let's go to retune, and we are kind of cheating, but let's find
I think it's 20, 50, 100, 200 in retune.
Yeah, in retune it starts with 30, so let's go like 50. How about that?
50 is good. For bassier notes, you always have to like go up in the window size, which makes sense.
Yeah, so let's do maybe 100.
Length is longer.
And then we can do
100
like bass
is good.
notes. So this is going to be the length in samples. And this is going to be in milliseconds.
We could also use 2048. That is more or less the frequency at a sample rate of 44.1 that transitions between audible and inaudible audio. It's like around 20 hertz. Which is the reason why it's often used, for example, for wavetable implementation.
Interesting. I didn't know that.
So it might make sense in cases like this too. I don't know.
So what is the number again?
2048.
Ah. Okay. I will want to keep this in case we want to play around with the window length. But
sure.
Yeah. Okay, so this is the window length. This is going to be the count of how many zero crossings we found in that window. But there is another thing we need. We need to keep track of when the zero crossings occurred, because we have that sliding window over time. And when a sample falls out of the window, we need to subtract 1 from the zero crossings, because that zero crossing no longer counts. Right? So I'm going to say that this is the zero crossings count. Does it make sense what I just explained?
It did to me. I don't know. Don't ask me.
I don't know. Let's just write something down.
Okay. So the zero crossings will be a circular buffer. I'll call this the circular buffer. And we will have an index into this circular buffer. So this 0 here is an address. Think of this as like malloc, okay? This is the result of calling malloc. This is going to be the base address of this array. And this is going to be the index into the array. So even though they both look like zeros, this is an address and this is an index. It is kind of...
Every variable in JFX can be a buffer or what?
No, the way it works is when you do something like this, JSFX will add these two things. So if you have something like base, address, and index, what it will do is it will do base address plus index, and then it will look this number up on a big chunk of memory that you have available to you. And that is the only kind of structure that you have in terms of memory access. And when I say memory access, I mean heap. That's the only kind of structure you have into the heap. And yeah, so that's how this goes. It's not the most straightforward thing, but it is what it is. So think of this as me like allocating an array of this size.
Okay.
And then what we will do is we will first manage this thing. I do want the index to go up, and if it reaches the size, then I will want this to wrap back to 0. Some good old circular buffer management here going on. And then I will always want to take my count and subtract whatever I find in the circular buffer at that index. And if I found a zero crossing, I will want to take that position in the buffer and put a -1 in there, so that later when it comes around, we will be subtracting. Or I guess I will put a 1 there so that we are subtracting this 1 from there. And I will want to add to the count like so. And if it is not a zero crossing, then I will put a 0 there.
Interesting.
I think that this does it.
Let's give it a go.
Just checking if there isn't something like obviously silly. But I don't see anything obviously silly, so let's try it.
There's nothing in it yet that overrides the frequency.
Oh
what
yeah,
are
that
we
is obviously
trying?
silly. So what we need is at the end of computing this, so here we are modifying the count. Now we need to take the frequency and assign to it. And I guess it's going to be the same formula, sample rate divided by the number of zero crossings. No?
Doesn't that have to be in the loop? Not in the loop, but in the, sign check? Checking if sample and sample
No,
previous
we
is
are always updating
different?
the frequency based on what we have seen. And the window is sliding, and we are always updating the frequency based on the latest window. And the window has already been updated at this point, both the count as well as the index itself.
Okay. I
So
was just wondering, because you're updating the count all the time, so that would mean that the frequency updates all the time.
exactly, yeah. But for the most part, this will be stable because most samples don't cross 0.
Okay.
But yeah, we could probably keep track of the previous count, and only if the count has changed do we update the frequency. But I think that's a moot point. So if we have a count of something like, let's say 2 zero crossings, we divide it by 2 because we cross 0 twice in the period, and then we take the sample rate and divide by that. I think that this is what we want to do. Am I right?
I mean, let's test it.
Okay.
F9, damn.
Well, this is not correct, but it is in the ballpark.
Wait, no, it's 101. Or is it just not, or do we just not have the enough window?
Yeah, it is
Oh,
going
it's
the
the
other
opposite.
way.
Oh, jeez.
Yeah,
I think the S rate, yeah.
maybe
yeah,
it's the other way around. Nope, that's still not it.
then it could still be multiplying the two values or doing 1 divided by
Doing
multiplying the values.
something, yeah.
Something like that.
Because the values, like the decimals in the end, kind of are in the ballpark. So it seems like a multiplication.
Either multiplication
isn't it?
or 1 divided by multiplication, the things. Usually when such a problem occurs.
Yeah, let's
I
do a
would say.
base frequency of something like, what is 48 divided by 4 again? It's 12. So let's do 12. And then we know how many zero crossings we expect to see in 1 second. Maybe this frequency is not good. Let's do...
Why don't you do 1200?
Like what I wanted was to have like yeah, that's much better. So we know that in 1 second we will see like. Is there a way for me to have an integer number of zero crossings?
Sure.
What
you just
frequency
have to
did you pick?
sample rate divided by 2 or so.
Yeah. So 1200 is
That's
sample
what I
rate
thought.
divided
That's
by
what
20.
I thought, but that's not correct.
Yeah.
If sample rate divided by 2 did not give me an
But
integer
that
number of
was
zero
not sample
crossings.
rate divided. I mean, which sample rate do we have right now? 44.1,
48.
right?
Oh yeah, no. What I
So it
wanted
would
was not
be
only an integer but a small integer.
48. Okay.
Like 3?
You could divide by
2,
4.
I guess, would be perfect.
2 or 4 or 8. One of these.
You can even 48k divided by 3 is 16, which is a pretty round number. I like when it goes.
No, yeah, I'm being stupid. I don't get it. I don't know how to make this like. How do I have a sine wave that cycles exactly once per second?
Do 6,000. That's 48,000 divided by 8.
Well, if you want, so then you want a sine wave whose period is 1 second, correct?
Yeah.
That would equal to the speed of sound, which is like 343, I think. That way in a second, it'll go, right?
Yeah, I just wanted that to make things easy, but it seems like it's not giving us anything easy to work with. So let's just go with something like this. And the frequency is, how is it changing?
343.
It is getting bigger. It seems like it's off by 1,000.
I think
Yeah, like the decimal point kind of.
It seems like it's off by 1,000, and I don't really get it, but I will multiply by 1,000 and see if we get there. It seems like it's still off by 1,000. But it's in the ballpark, isn't it?
It's getting in the ballpark, sure.
1,000 times 1,000.
And does it make sense for me to include the sample rate in this computation to begin with? Because we have a sample count, zero crossing count in terms of number of samples, but we should be thinking of this in terms of milliseconds. I want to think of this in terms of milliseconds. That's why I had this variable to begin with. But I guess I'm just being, like, stupid.
Well, but isn't the sample rate a roundabout way for us to get to milliseconds since...
Yeah, you know what I'm going to do? Real quick, I'm going to comment out this window. I'm going to bring this back because I am sure that this will be correct.
Yeah.
And then we know how many samples, how long this takes. So if we had a window of 1 second... my brain is fried. I think we want to do it like this. And this should work, right?
Window length in milliseconds divided by...
Because a frequency is how many cycles per second. No, it's the other way around. How many cycles per second.
Mm-hmm. But now you're doing how many cycles per window length, which is not a second right now. It's 1/10 of a second, right?
Right.
So then So I guess either set that to 1,000 or times it by 10. But you're
I've set
getting the
this to 1,000.
frequency. Yeah.
I'll set this to 1,000. And
Or times it down the alternative.
sorry, what was that?
Funny. Nothing. The alternative thing that I suggested was very weird.
Again, we are sort of there, but we are off by 1,000.
That seems pretty good. Just multiply with 1,000 now.
Yeah, but why?
Yeah.
I don't know. As long as it works, it's cool.
Oh, your window length in milliseconds that we set to 1,000. That means. Oh, but hold on. Sorry, can we go to the code one more time?
Well, it is a window, so it is like sliding, but it's spot on, and it's not jumping around.
Noise.
Yeah, that's really nice.
Very cool.
But I feel super silly that I cannot get this right. So let's fix this.
Window length. Okay, so you window length times sample rate divided by 1,000, right? So it's 1,000 times 4,800 or 48,000 divided by 1,000, which is 48,000, which is weird. You know what I mean? No, oh, that's correct, because 48,000 samples is 1,000 milliseconds. So that bit is correct. Then the rest is just zero stuff, zero stuff, zero stuff, zero stuff. Then can you scroll down? Because the bit I'm looking at is under your camera. Yeah, there we go. Boop, 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 boop. Boop 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 boop. Well, the part that I get lost is the index shit.
Well, but you just have to look at this, because the rest we proved correct. And I guess I can justify the multiplication by 1,000, because we want the frequency in terms of cycles per second, but this is given in milliseconds.
Oh, Tail has a correction in the chat. You want to read it? It's easier to read it than for me to speak it.
I am not with the chat open right now.
Okay. So it's Tail is saying, so that line that you have, count divided by 2 and then divided by window length, times that by sample rate, not by 1,000. Times that by S rate.
Shouldn't we
Oh,
also
but
use the
you're-
window
I
length and
think-
samples?
Yeah, that's for the window length and samples, but you're already
Yep.
computing that with samples.
Yeah, no, I think this is 1,000, because we want this to be in
Because
terms
it can't
of...
be 48,000.
No,
Then
so
it'll
if you
fall out
the
of-
thing is, if you look at this is the number of cycles per millisecond, but the frequency is the number of cycles per second. So multiply by 1,000. Now that I thought about this, this is the correct thing. This is what we want to do. I like this.
Nice,
I like this
nice,
equation.
nice.
So this is taking
Love
the
it.
number of zero crossings and giving us the number of periods. This is giving us the frequency in millisecond, and this is giving us the frequency in seconds, in hertz. That makes sense.
Nice, okay.
And I will even say that this is the unit of measurement here. So now, with all of this out of the way, I think that we can change the window length, and the thing will not ramp into the right value, or maybe it will ramp into the right value faster. Let's try this.
Hey, that's nice.
So yeah, it is at the right value, and because the window length is smaller, I guess it is jumping up and down a little bit between 7,900 and 7,905. So it's sort of missing a couple hertz, but it's not too bad, and it is moving relatively quickly.
Yeah.
I don't
Go
hate
to
this.
the
Really
lower
good.
end a little more. Like, go, yeah. It feels more, no, I was going to say it feels more accurate, but no, at 217, it was going 15, 20, 15, 20.
But it's good enough, I think.
Yeah, it
You
seems to
usually
like
don't use
multiples
pitch
of
tracking in
5.
the low end. If you
Okay.
used FFT for pitch tracking in the low end, then you would just be completely lost.
Oh,
So
really?
this is yeah. I mean, you know how FFT works in the low end. It just completely messed up. So this is way better.
Yeah, the problem with the low end is that at these frequencies, the bins are much larger. See,
Yeah.
the peak here is much thicker than here. And that's because this is in a logarithmic scale. So over here, the bins are much further apart in this drawing. So to get good accuracy on the low end, what you need to do is increase the FFT size. Or you can interpolate
So
some
what
zero
I
samples, but increasing the
would
FFT
suggest
size
is-
amounts to the same. And this gets you better accuracy over here on the low end. But our approach is not really is not really affected by this.
So my idea would be that we use the formula sample rate divided by frequency to come up with a length of our buffer, because that way we can sort of set the lowest frequency at which it should still be kind of accurate, and everything that is lower than that, it will not work very well, because we know that, you know, the goal of these kind of things is always to so that it works with certain instruments like vocals, and they have a certain range. For example, you could do sample rate divided by 100 if you think that the lowest frequency is 100 hertz, and that would be the length of this buffer then.
You know, what you're saying, I think, makes sense to me if you think about the frequency domain approaches, the FFT approaches.
No, I mean for this thing, because you have this buffer, and the length of this buffer seems to have the influence on how accurate it is. And I think it would just make sense to let this depend not in milliseconds, but in hertz, because musically speaking, you always think in terms of what is the lowest frequency of the sweet spot of my instrument, and not what should the length of some buffer be, you know?
No, I get that. Yeah, I think it makes sense. But one thing that does not make sense to me is how to relate this to accuracy to pitch. How would you relate accuracy to pitch in this approach?
I mean, if you had a frequency going in there that is lower than the frequency that we defined at the start, it would mean that it takes a longer wave cycle than the size of the buffer, and that would mean that we don't get accurate results. But we would get accurate results for everything bigger than that. And the benefit of that is that the buffer would have a size that is really low for every valid value. For example, for 100 hertz, it would be only 141 samples long. And that's just really useful, because that way we get low latency on and still accuracy for every value where it's needed.
Yeah.
Like the reattune approach.
Yeah.
Well, I
Yeah.
guess in retune, it is giving the window size as a parameter, and that's what we are saying we don't want.
That's in milliseconds, you know. But I think that's the problem, and that's the problem with a lot of Reaper plugins, that they are not made in musical
Yeah.
values, but always in some cryptic values that you have to put a little thought into if you want to use them.
This is true.
I find it amazing that our approach works all the way from 20 hertz to 24 kilohertz. It's amazing to me that it's working so well, even though it's so simple. So I guess
it should still work the same then, only for the lowest frequencies, not so much. But
well, the
then
low
at least
frequencies
we
are
can
fine.
decide at which. Yeah, but then we could at least define at which low frequency exactly it should stop working. And at the moment, we just approximate that by using some small millisecond size. That could mean anything. You know what I mean? It's just a little bit of a code cleanup thing to do that.
Yeah, let's see if we can make this problem occur, because our window is so long that we are getting good accuracy on the bass. Let's do like third and in retune, that's the default. And we know
Yeah.
for a fact that this does not work well for tuning the bass guitar.
With bass.
So, yeah, let's see what comes out of this.
Tail says 441 samples would be too small because you still need a good average. Yeah, because 441 samples is like 10 milliseconds in 44.1 sample rate, right? So pretty small.
Yeah.
Even with this window, which is very small, we are getting accurate results in the low end. It's not as accurate as before, but it's not terrible. If we were to smooth out the 33 with the, 16, we'd still get around 20. So it's not terrible.
Well, then we can keep it, I guess. I just feel like it's a bit weird to have milliseconds within DSP code. Usually something works best when you just have directly the samples going on. That's why I didn't understand it at first, I think.
Well, but you know what could be interesting is to try and work with other kinds of waveforms.
Yeah, let's go on with that.
Because I think that may break things. Because the sine wave...
Yeah, let's use your voice, in fact.
Or maybe the other basic waveforms, just to find out what that would be
Yeah, I
like.
wanted to do some basic waveforms first, but then I want to do some instruments as well, like the guitar or a piano and something. So this is us right here. These are all the measurements, and a sine wave is doing well across the spectrum. A triangle wave is doing good.
Yeah, should be the same. I cannot see the window, though. Where did you put it?
Because there's one thing about
Here, how about
all
that?
these
there.
extra waveforms, though. Like these extra waveforms, they're still synthesized, so they would still have the same number of zero crossings. If you think of a sine wave in 100 hertz, you turn it into triangles, it's still the exact same number of zero crossings in the exact same spot.
Yeah.
If you use like an acoustic sound, sometimes those things like weeble wobble, occasional squabble. So
Not just acoustic sounds, even lots of wavetables and stuff. But
Right,
it's good
yeah.
that we have tested all the basic waveforms just so we have good fundamental basis also.
Yeah.
So now we can go
Zoop,
on
zoop,
with
zoop.
complex signals.
Yeah, let's go to more complex signals. But maybe with a little bit of control first. Here is what I propose. Instead of the simple tone generator, let's put ReaSynth in there.
oh baby,
And
oh baby, oh man,
oh, it got the C right. That's 0 hertz. That's right.
nice.
And then, how about we put an item here with some MIDI notes. Now I have to close all the windows.
Get
So
get
what's your goal
yourself some
now?
screen sets.
Do you want to make just some synthesizer sound that is more complex, or what's the
Yeah, I'm
goal?
going to start stacking up sine waves and try to make the shape of the wave cross 0 more times to make this fail. I wanted to get a
Okay.
upper harmonic. That's what I'm thinking about. So
Yeah, or you could also just use an FM synth. They are all also often very wild when it comes to zero crossings.
oh yeah, that's a good point. But this is what I have right now. So it can
Okay.
still do all the weird shapes.
Things.
And
Oh, there was something.
Yep, we already got
Add
something.
an extra sign and then change the tune too. You can do that.
But we don't even need that. Check this out.
Oh, we already got Yoinkerstown with
Yep.
a square wave, right?
I'm mixing a square. If you put a pure square wave, it gets it right. The problem is in between, because look at the oscilloscope here.
Because those little, devil horns.
Yeah.
Very nice. Well, not very nice, but very, yeah.
But it still doesn't seem to break the implementation a lot, if you look at it.
Yeah, it is taking the second harmonic here because the pitch is around 400, I think. The pitch was, no, it was not even the second harmonic. It was not
Well,
even
you played a C, you didn't play an A.
Yeah, no, but it's like 266, and I believe this is right.
At which frequency are we? For real, I mean?
This frequency. This is the right frequency.
Yeah. So what's the problem?
This is the problem.
If we go up. Yes.
And we can see the problem in the oscilloscope here. It is this extra
those little
zero
teeth.
crossings.
Yeah. So that's weird though. We're getting extra zero crossings. You would think the frequency that it detects would be higher, but it's lower. What the hell?
No,
Or
it is higher.
It
is higher.
Oh, okay.
It's going from 250
it's
to 800.
750. I thought it went to 75, and I was like, what?
Yeah, that seems to make sense.
Florian, did you mention M synth just now, or
What? No.
no?
No, he
Okay.
mentioned
Thought
FM
this-
synthesis.
You're tripping.
Yeah, FM synthesis.
Yeah.
Also, any synthesizers with unison would also work very well
Yeah.
for making diffused phases and stuff.
Well,
and that's what I
in
mentioned.
ReaTune 2, you can have an extra sine mix and then tune it to something else if you want to really wild out. A wobble, 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 wobble.
Well, it's too close to the original, so it's not throwing off anything. Now it is throwing it off. Oh, hang on.
Cool.
Wobble, wobble, wobble.
No, this is not right. It is not mixing in an extra sine wave. It is just taking it out. I didn't know that.
What do you mean?
That seems to be a good signal.
Yeah, so
Yeah,
I
what
didn't
do you
know
mean
this
it's
about.
taking it out though.
I didn't know this about ReaSynth. I thought that the extra sine mix was gonna go from 0 to 1 in a way that 0 meant no extra sine mix and 1 meant the sine mix plus the original signal. But no, it is replacing the thing. So it's like a dry wet, and at half,
If you
get
if
both.
you set any of those wave shapes to 1, that means it's that wave shape.
But I think now you already mixed two different problems with each other. One of them is that the second harmonic is now louder than the first one. That's one of the problems, and the other one is the one with the phases that create multiple zero crossings. So we should focus on one of these first.
Wobble, 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 wobble.
Yeah, like that. Now we have only the problem with the diffused phases that we can solve.
but it's
try to
managing it all right. It's not being thrown off by the thing.
Not much, yeah. But why? Why does it still kind of work?
Well, I guess
But,
if
like,
we look at the
click on
high
the
level thing.
analysis, the zero crossings don't move.
Not much.
Because when you like pitch shift by very few cents, we actually we perceive it more of a volume fluctuation, but that's also what happens IRL, right? Like if you play 440 hertz and then you play 441 hertz, exactly one time per second they completely cancel out, and then one time per second they double each other. We don't really perceive it as two separate frequencies. They become amplitude because they start in phase, then they go way out of phase, then they come way back in phase. And if you make
Does
it like
Reaper
400,
have a wavetable synth also? Maybe we should just take a wavetable that has a bunch of zero
I don't think
crossings.
Reaper has it, but do you have Serum, Leandro?
I
Or
do not
Vital?
have Serum, but
Or Vital?
I don't have Vital installed. I can install it real quick, but I also have Surge, and that has a
So that
wavetable.
should be cool too. Yeah, sure. Or I guess even with the
Fernando
normal-
is asking, could it be done instead of using zero crossing with the maximum and minimum amplitude values?
That's also problematic because some
Yeah.
wavetables just have them kind of all over the place.
Yeah, like they're like wibble, wibble, yeah, like they're really weird shapes that.
Do you all want to vote on a
Unreliable.
wavetable here?
I mean, just try to build something
Just
that
whatever
has
guitar high.
you could probably also just turn these parameters a little bit. Okay, that's pretty much very
That's pretty jagged.
yo. So
So
now we have something that should still be what was that 250 hertz or
250
so,
hertz.
but now we see 2300, which means that now we can
Yikes.
try to improve things.
Yeah, so zero crossing is not great, is it? But autocorrelation could fix this. But
First, we have to make sure that the fundamental frequency is still the highest in volume. Otherwise, we have to take care of two problems at the same time.
I think so. I don't know. Let me think about this for a moment.
Fotis, you gotta be VCV rack.
Autocorrelation could work even in this situation in which the second harmonic seems to be louder than the fundamental. Or is it the first harmonic? How is these things counted? I never know. I'm a computer scientist. I count at zero.
It's the second harmonic first O tone.
No.
That's how you can think about it.
Anyway, so even in this case, I think that autocorrelation could work as long as you are smart enough to start from the left. So you can
Started from the bottom now.
let's do the simplest autocorrelation algorithm in
Ever.
our heads, because implementing it is too silly. But we could do something that is like, is it 1 hertz? To tell if it is 1 hertz, look at 2 periods of 1 second, overlap, and look at the correlation. Does it correlate well? If so, 1 hertz. If not, move on. Is it 2 hertz? Half second, correlation, is it good? If so, 2 hertz. If not, try again. Is it 3 hertz? 1/3 of a second. Auto take 2 blocks of 1/3 of a second. Look at the autocorrelation. Is it good? And so on. And if you keep doing that, at some point you will find, oh, is it 255 hertz? Oh, okay, that's a good correlation. That's my output. So as long as you're smart
You know
to
what
go
I
from
always
left
don't
to
get?
right, it should get it.
What's the difference between all this autocorrelation stuff and just getting the FFT of things?
Well,
always
one of
seems to
the
be the
differences
same
is
thing.
that one of the differences is that the window that you're doing the autocorrelation with, this naive approach I mentioned, is not the way that people do autocorrelation. There are smarter techniques to doing the windowing and the sliding and whatnot. But you are right that it has to do with a window, but it's just not the same kind of wait until you get 4,096 samples and then take the FFT. It's like our window here. We are still using a window, but we are being smart about the way that we update the window and the way that we use the window so that we get results with almost no latency. Does that make sense?
Yeah.
Not really?
I don't know.
You know what we could do? We could, for next time, bring in one of the autocorrelation algorithms and implement it, and then everything that I'm talking about, I think, will make more sense, hopefully.
Yeah, these kind of things are really hard to write from scratch.
Yeah.
Yeah, you mean
Too much.
You mean it's hard to write from scratch the implementation of an existing paper, or to come up with the idea from scratch?
I mean, autocorrelation stuff in writing that down spontaneously.
Oh,
Or maybe I just feel like that, but I always feel like these kind of things take a little bit more time.
yeah, we can study things and see what comes out of it and see if it makes sense to try and implement it, or if we should just look at an existing implementation, because there are implementations, I think even in JSFX, of autocorrelation and this algorithm. So we could just pull them one off the shelf and play around with that.
But what kind of things do you correlate with each other? In the case of FFT, for example, you are trying to find a correlation between the input signal and a bunch of sine wave and cosine waves, right? So what is the autocorrelation algorithm correlating the input signal with?
Itself.
Oh,
That's why it's autocorrelation.
okay. Yeah, I guess that makes sense. I would have to try to really get a feeling for that.
Yeah,
though.
you take the input signal, you slide it in time just a bit and correlate it with itself.
Yeah, I once wrote cross correlation, I think, if I understood it correctly, because I once tried to make a plugin that I never released, by the way, because no one knows it, and I wanted to have something that can line up two drum samples with each other in time. It actually worked, but it was just not ready. So what I did was, when the drums occurred, which was made with onset detection, then I sampled the two drum samples, and then I tried every single configuration where how they could overlap, and the one that worked the most, the one that correlated most, that was just the one that I then defined as the delay offset that is being used. And what I want to say about this is I had to make so many checks in that, cross correlation, every single offset was tested, that this would just no way work in real time. It was something that only worked because I was triggering it from a single impulse. But autocorrelation can be considered because apparently it computes much better, but I don't understand yet why.
Me neither.
Okay, so I'm just going to bring up this. So I think what I am interested in doing is reading this YIN paper and try to implement it.
I've heard of Yin.
I wanted to read this paper and implement it. If it turns out that it's too complicated, there is this JSFX library with the implementation. We can just pull this off the shelf and play around with it.
Kawa? Nice.
That would be cool.
Yeah, but I think we should be able to read the paper and implement it from scratch. I mean, how hard can it be? Famous last words.
Pretty hard. If it was
Famous
easy, a lot of
last
people would have
words.
already made plugins like that. I mean, autotune plugins, for some reason, there are only a few of these on the entire market, and even less of them are free, so there must be a reason for that.
Yeah, well, we'll see. We'll learn. It will be fun. I will assign this as my own homework if you all are interested in following up with that. I will
Sure.
I will learn about this, and we can
Yeah.
try and implement this together. It will be fun. And I guess this
Yeah, that
implementation
does
was
sound
kind
like
of
fun.
adapted from some other libraries, so we could always try that as well. But anyway, we can look
Sure.
into this and learn how well it works.
So what does the yin method do though? Like, it's not windowing and it's not autocorrelation. It's a whole other thing.
It is still autocorrelation.
Oh, okay.
Let's check the paper real quick. It is based on autocorrelation
Okay.
with a number of modifications that combine to prevent errors. Error rates are lower. Nice. There is no upper limit on the frequency. It is relatively simple. We'll be the judge of that. And it is low latency. So I guess it kind of fills many of the boxes we are interested in.
Yeah.
What does it even fail at when it has all these benefits?
Maybe
Well,
it's not
still
too
like
good
not
with
saying
noise.
no errors.
Well, we'll see, I guess.
Yeah, we'll learn. It's It's right
But
here
it's
in front of us. We'll
Kinda
figure it
too
out.
good to be true. Something there has to be
Too
a
good to
compromise
be true.
somewhere.
Something's got to give. Yeah, I agree.
I don't know. Just when I see these kinds of things, I am always like, we need to implement this.
That looks very FFT. You know, sums
True.
of lots of things.
Joseph is saying you can do autocorrelation cheap. Check Wiener-Khinchin theorem. Khinchin? 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 One of those would be about right. Do you know of this? The Wiener-Khinchin theorem?
No.
That's something to check out.
Okay.
Yeah, there is one more thing that we need
Joseph,
to do,
you
and that
some
is
plugins,
we,
right?
we want to test this with real audio too, right?
Yeah, let's use your voice.
My voice is short. Let's use an ukulele.
Sure. The
So you
uke.
want to use the current implementation for testing?
Exactly. Yeah.
Yeah, I think.
Cool, cool. Yeah, that would be interesting to know how that works. Guitar should be pretty good.
We take this out, enable this for recording, and set this to my microphone. And
You're
this
currently not sharing your screen, by the way.
Oh yeah, good point.
Now
There we
you're
go.
doing it.
And here it is. This is the setup, and
It's doing something.
it is doing a lot of something when I'm quiet, and that is because it is receiving essentially noise and treating
Yeah,
and looking at the
trying
number of
to
zero
analyze
crossings
it.
in that.
But that's okay, I think.
We can like, I mean, even like putting a gate in front of the analysis, we'll just get rid of that, right?
Exactly, yeah. So let's not worry about this. Let's worry about trying to tune the ukulele. What is the frequency of G4?
don't
It
know.
is. I don't know. It's around 427,
Frequency.
something like that. Or no, that would be
notes.
the G sharp. Yeah.
G4 is 392.
392. Yeah. I did get G sharp because I'm an idiot.
Why do you know the frequencies?
I just rough math, and I mean that's from integer ratios, which in 12-tone equal temperament, it's not the same.
You know
Oh,
what I just
something
thought?
happened.
That is weird. Isn't
Good.
it stuck at 383?
It got to the right frequency at times, but then there were a lot of outliers. Maybe we could use a statistical algorithm that is used to, filter out outliers. There are a lot of these kind
Yeah.
of things in statistics.
Because I think as the sound decays, it just defaults to like whatever. And something I've always found interesting is that guitar noise always feels, if you put guitar noise through a guitar tuner, it's always a little flatter version of G sharp. I don't know why. Has anybody else noticed this? I didn't know where my camera.
I'm trying to tune now C4, which is 261.
Why do you know that it's G sharp? Do you have perfect pitch?
No, I don't. No, I have very, very good pitch, but not perfect.
Okay.
Like if you play me an A in the morning, I can pretty much get through the day having decent pitch. But I lose it when I wake up. Every morning I wake up.
Okay.
Something like that.
So yeah, this is the waveform I'm getting from the string, and it's not too bad in the sense that it is not crossing zero too many times. So maybe it is in this region here. that the
Yeah.
zero crossings are happening. Like if we zoom
Can
in,
you zoom? Yeah.
Oh, there is a very tiny spike. You see that?
Yeah. That's
Yeah,
the reason
as
why
zoom,
it
zoom.
this
fluctuates so much.
this is not good. So I say that we fix both the problem of me being silent and the thing is still tracking, and this problem at once by putting a small gauge. If the difference between
Sounds
two
good.
samples is too small, we don't count that as a zero crossing.
I
Goodbye.
would just use a low pass filter on the input signal actually, because if you think of it, a smooth signal would not do this wiggling at high frequencies.
Fair.
So we just have to decide for the most uppermost frequency that we want to have, and we just cut rigorously at that frequency.
I think 5K. Cut everything past 5K. Goodbye.
Let's go.
Okay.
The highest fundamental of a piccolo flute is 5K, as Bo just looked up.
Let's just put a really
So-
steep low pass there.
Yeah.
Oh, we want it to be steep. Let's go rear for.
Yeah, or at least have control about the steepness. Maybe steep works better, maybe not. Let's see.
I'm dying here.
I have
Yeah.
a question. Do you use Reaper stock plugins exclusively when you are making music? I know that's a bit off topic now, but I'm just curious.
Not exclusively,
I
no.
think Leandro, you do a lot of free stuff overall.
Yeah, but not exclusively. I tend to use Reaper plugins because I got used to them. They work very well. They give me all the power I need, all the flexibility I
Yeah.
need.
Oh, that's really steep. Yes.
Uh,
Let's see. Maybe it is too steep because steep filters sometimes cause ringing and stuff like
Yeah.
that. But maybe it is just right. I don't know. Let's see.
Yeah, so this is what it looks like now.
Zoop, 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 zoop.
I have
zoop.
too many windows. I am looking for the window that lists the plugin. So the filter is coming first, and our detector is coming last. And still, of
Now
course,
try
reacting
playing
to
some
noise.
And if you now play something,
Hey, that felt pretty stable.
yeah. See, that's what I expected to happen.
It said 383 and it's 392 if it was tuned, so that's quite decent. It was saying 383 before though. What the
It's
fuck?
stuck in 3.8. It's stuck there. I think that we need a bigger window.
Interesting.
Let's do a bigger window.
Let's try it. To the window.
I think if we now put a low pass filter on the frequency itself that we generate, then it should be averaging to the right frequency.
To the right
because
place.
Yeah, because it already spends most of its time being there. So a low pass filter would just make it get stuck there.
Mm-hmm.
So now we have a bigger window. That should improve things.
395, is that what I read?
It's still not good.
Pretty much the same, I would say. But I would still say that it's already pretty good. Why do you say that it's not good?
Quite decent.
I mean, for an approach that doesn't even use FFT and stuff like that, I would say it's pretty cool already.
Yeah.
It's not terrible. I think I could tune the ukulele with this.
Maybe we could, while we're at it, also add a high pass filter to just get rid of the rumble of the input signal, to let it prevent to be triggered by that.
So
Yeah,
just
because as the note decays, we start to get something kind of below the old fundamental.
Let's just think, what is the lowest frequency of a guitar? I don't know, something between 100 and 200 or so.
On a regular guitar or on a uke?
Oh yeah, that's just a ukulele, so we can go pretty high with this filter.
It's probably the 260 of the C, right? That's the lowest you get. Dun, 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 dun. That one. Yeah, that guy.
It's pretty
Now
good. It's pretty
that's
good.
Pretty good. We have no big jumping around anymore.
Pretty good.
I wonder if there is
I
a quick
also want to
formula.
try one more thing. If you can, Leandro, which is like the ukulele decays pretty fast. What if we had like a sound that was more sustained?
Um,
Then we could look at the frequency better at least.
I see what you mean.
Like a stable your voice.
Okay. No, yeah, I think I
like
will
that.
just record something real quick.
Sure.
Hi. Oh, hang on.
No, there was something with a big pitch drift in it, but maybe that's
Yeah.
still pretty
But
good.
that's a good test too, yeah.
The waveform already looks like something that should not work too well.
Yeah.
Yeah.
Let's see.
And for comparison,
Oh, actually,
here is retune, which we trust, right?
Relatively. That was 94 hertz though. That felt a lot higher than that. And it felt a lot lower than like 700 that the other one is saying.
around 90 hertz makes more sense to me.
Yeah, it's closer for sure, but I would have thought it would be a
definitely.
little higher.
It's definitely higher though.
Nice.
Are you trying to sing the same note as the guitar now, or
Dun.
the way you could create a tone where we know the pitch more or less?
No, my idea is that I'm going to loop this part.
Oh,
Sure,
okay.
though.
That's just
'Cause
too easy,
otherwise
isn't
we
it?
could have- Otherwise, we could have continued to experiment with vocals.
But that's more or less what you wanted, right? You wanted some kind of waveform that would repeat like this, but it was just the tail end repeating. So that's what I did. But
Okay, yeah.
it kind of looks like a sine wave. Well, my voice is still going through this, but when I stop speaking, you can see that it's sort of like a sine wave.
Yeah.
Yeah.
Too close near the decay of the thing. At the beginning where shit is kicking off.
We're still pretty good
Yeah.
there.
Still pretty
That's
good.
good.
And I mean, there's a natural like wobble because it's like the pitch does wobble. It goes
But that's normal for guitars.
boing. Yeah, exactly. Like it always goes up to fundamental and then starts to go back. It sounds like
At the transient, the frequency of a guitar is a little bit different. And then it quickly decays to the frequency that you have actually intended to plug.
Yeah, so
yeah,
can
what
I,
is that word, Andy? I think it's just it means German. I think that's what that word means.
So before I mentioned that I wanted to do something to the implementation,
Check the chat.
Oh, I don't have the chat in front of me right now.
me neither.
Oh wow.
What did
What is the
chat
chat
say?
saying? Hello, chat.
I'll write the word for you. I think it just means German from context.
I see. Yeah, I'm from Germany.
Yeah.
That was the question.
We have a fellow German fellow.
So I want to propose something. I think that,
Okay.
first of all, I don't like how when the signal gets noisy, we see these spurious like zero
Jiggles.
crossings. Because sometimes, let's try and find one. Well, it's not happening on this signal, but
What do you mean?
when we had a signal that was noisy, it was kind of going up and down, and we put a filter to fix that. But I think that there is a relatively simple solution to that also addresses the problem of the pitch tracker just triggering on silence or almost silence, triggering on room noise. The idea goes like this. We start by saying that we will not be counting zero crossings. And only when we get to a certain threshold do we allow a zero crossing to count. So this is effectively putting like a limit here and a limit there. And only when you cross that threshold are you allowed to count zero crossings. So this should get rid of the little noise we get over here. And it should also just stop the pitch tracker dead on its tracks when it is not listening to any signal. Do you want to try and do that?
That makes a lot of sense. Yeah, sure.
So my question is, once you exceed that, like, does it then at one point reset back to not allowing?
When you find a zero crossing, it resets.
Oh, gotcha.
Yeah, I actually know exactly what you mean, because my favorite visualizer plugin, which is Signalizer, I don't know if you know it.
Signalizer.
Yeah, it only works for Windows, so that you might not know it. But it's pretty cool. It has an oscilloscope as well, and there you can also let it be triggered by zero crossings, and then there is a little parameter for the threshold. And I suppose that it's just exactly this idea that is being used.
Damn,
there.
it looks beautiful. It's very nice.
Are you on the web page right now?
Yeah, I was just looking at it.
It's awesome. Best visualizer
So here's
ever.
how this goes. Let's see if it makes sense to you all. To begin with, we are not counting zero crossings, and we only count zero crossings if we can find a sample, any sample, that is bigger than a threshold. Then in that case, we are counting zero crossings. And then
I would make the threshold a parameter so that we can play around with that. You know, the slider.
yeah, okay.
And also for that it has a name. I always dislike when things have no name.
Oh, I agree.
Yeah.
I agree.
Leandro agrees.
All right. That looks nice.
I could have given this in dB, but I'm gonna do it in
Yeah, I was just thinking,
magnitude.
why not dB?
Oh, do you want to do dB? I can do dB for you.
I mean, that
Yes,
would,
to DB.
that would feel a little bit easier to use in the end, I think. Then we could use a range of, I don't know, -40 to 0 or so. Whatever.
Okay, I will do dB for you. I wanted to save some typing.
Yeah, but it also has to feel right, or else we don't know exactly what we are doing, I think.
True.
Or at least it's always that way for me, you know, from a musician point of view. I can feel nicely into dB scales, but I don't feel nicely into just amplitude.
At -40, it gets a little hard. At the beginning, it's easy. You just half stuff until you get to like 0.125. Then the next one to divide is 0.6.
I have a question about JFX. Is there a way to sort of just say that every project should have some basic implementation and then you go from there?
You can make like a JSFX that you like as your default. Then you just duplicate that because it's a text file. So you can you can start off with some basics, and you can also import libraries. So you can have a bunch of code that you've written and just import them into a fresh window, and it will have like all the definitions and stuff that you've.
That's cool. I was just wondering because you know, you're always copying the formulas from other projects. And that could be...
No, what I'm doing here is I wanted this to be self-contained because I want this to be able to share this and people just can use it. But what this is actually a library, and you could import the library instead. And when you create an effect in Reaper for the first time, it does come with a boilerplate that you can follow just to make things easy for you. It's like a volume plugin. And then the library is a lot more stuff that I'm developing over the course of 1.5 years at this point.
You just don't want to make it look too complicated to people who just want to look at what you did.
Yeah, and that's why I wanted to avoid the DB stuff, because I wanted to avoid having to have this formula here. But anyway, now we have it, and now this looks correct to me. I think it is correct.
Good.
So let's try this. So if I am right, we can find Reaper in this whole mess. It's here. Then find Reaper in this mess. Then find refer and bypass it. And then reinsert the plugin like so.
Sweet. That is the threshold slider.
Oh yeah, and I'm still playing this. I will stop playing and I will stop saying anything, and this number should stop bouncing around. Isn't that something? What's happening there?
Also, what number is that? It's like fourth. It's like in the 6 digits.
It seems to just fall endlessly.
Yeah, probably. I have a
Some
mistake here in the
resetting
code. This should be that.
Okay.
And the thing.
And now find Reaper again in this fucking mess. You know what? I'm gonna start closing windows because I'm driving myself crazy here.
Ah.
By the way, you know, Leandro, when you take the plugin off and put it on, you don't really have to do that.
I know, but there are some things that go
okay.
bad when you don't do it. And in this simple plugin, those things would not occur. They mostly have to do with the user interface, the custom user interface without just default sliders. But I got in the habit of doing it. Anyway, it seems to be like getting to 0 and stopping there, which seems good to me.
Yeah.
Cool.
Then we don't have refer anymore, and we should be able to track complex waveforms like, I don't know, my ukulele, I suppose. Let's try to tune the uke.
Nice.
Very nice.
Yeah, that 260.
Hey,
260.
look at that, huh? Nice.
I would still try the filters if they still add something to the whole thing or not.
Yeah, like they definitely will the more complex the waveform gets to, because I mean uke like a clean is still.
Wow, that's even better. Look at that. Now
Yeah.
it really sticks to the value. So even on a very simple waveform, it's already a little bit better with the filters.
Do you want to try Surge again?
Yeah.
Well, let's try without refer.
Okay.
And we need to loop back here. Nope. It's still not good.
And now let's try with the filter.
Nope. Same story.
Oh. Why?
Well,
Yeah, why?
Look at the
this
oscilloscope for that?
waveform is crazy. It is a
Yeah, but
guitar
can we look at
high.
the-
What
let's
if it's
tr-
just a
let's look at the
guitar?
oscilloscope.
This is like a guitar.
Yeah,
But that's
this is
amateur shit. That will work, yeah.
Yeah. We need to look at the complicated situations.
This looks legit
Yeah.
to me. This
okay,
looks,
okay.
And now it's getting one overtone. And if we filter, one overtone. But if I play around, refer is off. But if I play around with the threshold, we should be able to get this right. And we do.
Oh,
Nice.
but it's a fairly high threshold, and it's
Yeah.
already becoming a little bit dangerous.
It is
For
cheating.
dynamic
I am just
material.
putting the threshold above this line here so that it doesn't trigger on this wiggle.
Yeah, that's the problem about this approach.
Well,
Also,
the problem
you see that
is-
the curve is a little bit async, so you see that every time a waveform is a little bit async, you have to take a higher threshold for it to still work fine.
Yeah. So I guess the threshold, which is currently static, could be moving around if you get to this kind of. I guess you could turn the threshold, which is a line, into an envelope follower. And then if you get above this line, then you expect the cycle to go up to this line as well. So the threshold will be around here. But if the signal gets quieter, then we move the threshold along with that. Do you see what I mean? Putting an envelope generator?
Will that introduce more latency?
Not really, because you are just doing an envelope follower pretty much like the ones you see in the meters here. There is no latency involved. It would be
Well,
just
there's
like,
always a little bit of latency in an envelope follower.
well, you can just take the maximum between the current value of the envelope and the sample that came in, so that if you see some sharp edge going up, you catch it. But then you let that descend in like an exponential fashion. So you let the decay be exponential, and that will introduce because we are talking about the waveform here. So this exponential decay can be really fast, and I don't think it will introduce any problems in terms of latency. But I don't want to implement that right now. I think that we
would
are out of time
at least
here.
still be way faster than FFT. So whatever latency it adds, it's okay.
Yeah.
It'll be tolerable.
Yeah. But the truth is that I am dying here. I need to go back to bed. So
Yeah, let's wrap this up. We're also just trying to not stream for like 5 hours all the time, so that maybe people should in the future. But well, that was first of all a lot of fun, and thanks Florian for being with us. But let's do this again. Maybe do it on Leandro's channel. Maybe do a circulation on everybody's channel, and then make all these people go to more channels.
Yeah, that would be cool. I haven't done streams, or actually I have made streams on my channel, but it's very long ago, and it was just about music production. But we could just make some. I was eyeballing with this concept anyway.
Nice. And yeah, maybe tell people about your channel a little bit, and also where people can get your plugins if you have any available.
So yeah, my channel is BasteIn, and I don't know if you can put a link into the chat because I'm currently not there.
It's linked in the description, but okay, I'm gonna also put the link here.
Yeah, and the description is fine, I think. And if people want to find my plugins, they can go to my GitHub page, which is also available from my channel. Actually, I don't know currently if it's even in the info page. Did I add it there? I do hope so. Let me check. And if not, then I also made a textual post lately where I enlisted them all.
I'll grab that link too.
I still have to put the list into my info section, but I will do that in a few minutes or so. And yeah, on my channel, let me just quickly say something about my channel in general. You can find there videos about sound design and mixing, and about plugin development, and also about testing plugins, because I love just first trying plugins to see what kind of first impression they create, because we all know that sometimes the first impression counts most when testing plugins for validating if we want to further use them or not. But sometimes I'm also reviewing them really in a more serious way after a bunch of usage beforehand to show something more specific about them. So my channel is basically about a lot of different things that range between musician stuff and programming stuff.
That's super cool. And you actually, I've noticed you use a lot of community posts, which really inspired me to do the same, especially when I get busy, to just talk to people. That's cool.
That's true. At some point I started making polls and stuff about mostly about UI UX things, because I wanted to know what the people like about sensitive drag and buttons and stuff like that. Because I just noticed there is not a lot of data for us plugin developers that we can pick to just know what we have to do. We just have to follow our vision. But it would be cool if there was just data for that, so that there is some sort of way to generalize certain problems a bit better. Everyone rolls their own solution. We can't even decide if Shift or CTRL should be sensitive drag. Juice, for some reason, thinks it should be CTRL, but most old plugins think it should be Shift. I think that makes no sense. We should decide for a standard so that everyone can feel more sure that all of their plugins work pretty much the same way on a basic level, and only what makes them special should differ. That's my opinion.
That would be awesome. That would be very cool.
Yeah, that's why I started doing these things.
Nice. Leandro, what are you got going on these days other than recovering?
So here's what I got going on. I forgot about this, but hey, I wanted to convert the frequency into a note number because I was tuning the ukulele and I was looking at the frequencies and they were slightly off. But then I reminded myself, hey, the pitch may not be too off in terms of cents. So I found this formula and I'm implementing it. Let's finish this and see what we have. So
Okay.
this is frequency, and this goes out, and that's that. And log 2 is something that exists in JSFX. Am I right?
69A.
No,
nice,
log 2
nice.
does
You got
not
a couple
exist.
of subs. But with the note number thing, I would say we're once again folding ourselves back into 12-tone equal temperament.
But that's the cool thing
wants you
about
to do.
this formula. You can tweak it to do other things.
I guess, yeah. You can make it 19 or...
I just want to be able to tune the ukulele and see how off we are in terms of pitch detection, not frequency detection, which is not quite the same thing, right? So I think that does it.
Yeah, sure.
Am I right that the log of 2 is the log of whatever divided by the log of 2? Do I have my logarithms right? I think that this is how you do it. But I forget.
I think
They were teaching
so.
logarithms in school. I had already discovered marijuana, so...
Yeah,
don't ask me.
same. So that was really not the kind
It's
of
all
thing that I
fun
paid
after.
attention to.
Yeah.
So let's take off Surge and bring back Resynth. That is producing, I think it's like a C and 260.
Jiggle, jiggle. Yes, 60 is C. 60 BC.
Is this note right? So it should
Yeah,
be
and 60.
around 60, and it is.
Yeah,
Nice.
cool. Then it works.
So it's not
Actually,
too bad.
it giving us the decimal, I kind of dig. Because it's like you're between the C and the B, which is kind of fun. All right,
that
I'll allow
shows the
it.
temperament of the note actually then.
Yeah.
So I can play with the frequency here, and as soon as I find the frequency,
Well, the frequency of Resynth is just by note, but yeah, you can detune it.
Wait.
Yeah, and you detuned.
Can I ask a question? Didn't you say like half an hour ago or so that you made a pitch shifter lately?
yes.
Yeah, a while ago. Yeah.
Let's try something fun. Let's put this pitch shifter into the script and let it shift to the nearest pitch, and then you can try to play the guitar and see if that auto tunes it.
Oh.
Ah, fun.
If we still have time for that, I don't know.
I really want to do that. I took note of it. It is on paper. I will not forget it, but I am dying here. I just wanted to make sure that we
so
cover this. And now
Stay
we have
tuned.
a MIDI note, and it is
Yeah.
relatively accurate. I really like where this is going for something as simple as
Nice.
43 lines of code. It's not too bad. Okay, so you asked me for about things that are happening on my channel. So first, I am working on JSFX stuff. I'm working on the auto mixer, which is this effect that helps you mix automatically a bunch of microphones that are open in a room. So think of an interview, a podcast, an event, a live event with many people in a panel, that sort of thing. And I'm working on a second version of my auto mixer. I have a first version. The second version will be fixing bugs, adding features, and adding visualization, which is a big thing. A big thing for me. I really think that we should see what we are doing to audio. So that's the first thing that is related to what we have been doing. But
So you have a beef with Air Windows.
no,
Is Air
not at all.
Windows doing an auto mixer?
Not at all.
No, he hates visualization.
Oh.
Yeah.
Leandro, I gotta say, at the beginning, you didn't like visualization so much. I feel like you're coming around to visualization.
Why do you say that? I have been big on
Maybe
visualization
you always
since grad
loved
school.
it, but oh, okay. Maybe you like were focusing on not visualization, and now you're starting to kind of bring it in to the fold.
Maybe. No, I always liked visualization.
Nah,
It was one of the things I
it's
kind of
good.
that I made an effort to when I was writing papers in academia and whatnot. I was big on showing things with visuals. Anyway,
Nice.
yeah, so there is the Automixer going. There is also a web application. So if you all are interested in web development, I'm working on Kill the Newsletter, which is this application I have to convert from email newsletters into RSS feeds. And I'm, again, updating it, fixing bugs, improving things all around. Then I'm also working on a data bending thing. So you take a video and you process it as if it was audio.
Oh, that's really nice.
You apply a tremolo to a video file, or vice versa. You take an audio file and you, I don't know, blur the pixels of an audio file. You misinterpret a media file on purpose, and the results tend to be interesting. So I'm working on this tool that helps you data bench at scale. You just throw a file in the thing, and it's going to spit out a bunch of data bends for you to evaluate, because when data bending, things are really hard to predict. So you just do a bunch of them and you see what you like. So I'm working on that. And I'm also tomorrow meeting with the C++ digital signal processing, JUICE, and many other things study groups. So people who are learning C++ digital signal processing and frameworks like JUICE are part of this group. And we talk about many things, from electronics to building samplers using kind of drag and drop tools. It is quite fun. And tomorrow will be probably the last meeting of the study group this year. So it is a great time for you all who are interested in this to join, see if you like, and maybe next year you can join us. Because we usually meet every 2 weeks, and 2 weeks from now, it's almost Christmas. So there is that. And I also talk about some fundamentals of digital signal processing, like how does oversampling work at the fundamental level. I have videos about that, kind of nerdy topics as well. And yeah, that's what I've been up to.
Cool. All right. Well, everybody, see you soon. I'm working on a video that's really long. It's taken too long, and I hate my life and I hate myself, and it'll never be finished. So you will never see a video from me again. I may just give up and do like a video to just have done thing while I work on this. But then I'm like, if I do that, I'll never finish this video. So probably like in 6 months, I'll release a video that no one will watch. Stay tuned. If Adam at Hot Pole is Man of Steel, Leandro is General Zod. Interesting.
It's always like that, Arya. You spend 6 months in one video, no one cares about it. Then you do a throwaway thing in 5 minutes, and it's your best video ever.
Yep, all my top
relatable.
videos are throwaways. I get, and you can't be like, let me make a throwaway so it's popular. It doesn't work.
No.
You gotta really not want to get a lot of views. I don't know. We'll see. So yeah, everybody take care of yourselves. Go tomorrow on Leandro's channel, subscribe, and hit the things to all the people. All the links are below. And enjoy the rest of your day.
And take care during Christmas time or whatever you are celebrating.
Exactly.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And so we'll be back together for some more coding or talking or chilling. The next time I'll be streaming.